When installing electrical disconnect switches, specifically 800 amps or 1200 amps fusible disconnects or 1000 amps in closed circuit breakers, the wiring can indeed come off the top lugs, perform a U-turn inside the disconnect enclosure, and then exit the bottom. This is a typical method for arranging load side wiring when it needs to descend to a lower level of the building. However, several factors must be considered to ensure a safe and code-compliant installation. The primary consideration is the available space within the disconnect enclosure. There must be sufficient room for the conductors to make the U-turn without being excessively cramped or experiencing undue bending stress. Consult the manufacturer's installation instructions for specific guidance on the minimum bending radius of the conductors being used. These instructions are crucial as they ensure that the insulation of the conductors is not damaged, which could lead to short circuits or ground faults. Furthermore, proper spacing between conductors must be maintained to prevent overheating. The National Electrical Code, or NEC, provides guidelines on conductor spacing in Article 312.6. This section addresses the spacing requirements for conductors and enclosures, including disconnect switches. The necessary spacing depends on the voltage and current rating of the conductors. Adequate spacing allows for proper heat dissipation, reducing the risk of insulation breakdown and potential electrical failures. If the internal space of the disconnect enclosure is insufficient to accommodate the U-turn and maintain the minimum bending radius and spacing requirements, external conduits might be necessary. However, in many standard disconnect enclosures, particularly those designed for 800 amps, 1200 amps, or 1000 amp applications, there is typically enough room to perform the U-turn internally, eliminating the need for external conduits. External conduits introduce additional installation complexity and cost, so avoiding them when possible is often preferable, provided all safety and code requirements are met. When routing the conductors within the enclosure, ensure that they are properly supported and secured. This prevents strain on the terminations and helps maintain the integrity of the connections. Use appropriate cable ties or other securing methods to keep the conductors in place and prevent them from shifting or rubbing against the enclosure walls. Another critical aspect is selecting the correct size and type of conductors for the application. The conductor ampacity must be sufficient to carry the load current without exceeding the conductor's temperature rating. Refer to NEC Table 310.16 for ampacity ratings of insulated conductors. Also, consider the type of insulation required for the specific environment in which the disconnect is installed. Factors such as temperature, moisture, and exposure to chemicals can affect the choice of insulation. The disconnect switch itself must be appropriately rated for the voltage and current it will be carrying. Ensure that the disconnect's voltage rating is equal to or greater than the system voltage and that its ampacity rating is sufficient for the load current. The disconnect should also be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or OL, to verify that it meets applicable safety standards. Grounding is another critical consideration for disconnect installations. The disconnect enclosure must be properly grounded to provide a path for fault current in the event of a ground fault. This helps to protect personnel from electric shock and prevents damage to equipment. Connect the grounding conductor to the designated grounding terminal inside the disconnect enclosure and ensure that the connection is secure and properly tightened. Inspect the disconnect switch and enclosure for any signs of damage or defects before installation. Check for cracks, dents, or corrosion and ensure that all components are in good working order. Replace any damaged or defective parts before proceeding with the installation. Follow all applicable safety procedures when working with electrical equipment. To energize the circuit before beginning any work on the disconnect switch or wiring. Use appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses, to protect yourself from electrical hazards. When making connections to the disconnect switch lugs, use the correct torque settings specified by the manufacturer. Over-tightening or under-tightening the connections can lead to loose connections, which can cause overheating and potential electrical failures. Use a calibrated torque wrench to ensure that the connections are properly tightened. After completing the installation, thoroughly inspect the wiring and connections to ensure that everything is correct and secure. Check for any loose wires, exposed conductors, or other potential hazards. Test the disconnect switch to verify that it is operating properly. Use a voltmeter to check the voltage at the load side of the disconnect to ensure that it is receiving the correct voltage. Also, use an ammeter to measure the current flowing through the disconnect to verify that it is within the rated capacity. If any problems are found during the inspection or testing, correct them immediately before putting the disconnect switch into service. Ensure that all covers and access panels are securely fastened to prevent accidental contact with live parts. Label the disconnect switch clearly to indicate its function and the equipment it serves. This helps to prevent confusion and ensures that the disconnect can be easily identified in the event of an emergency. Keep the area around the disconnect switch clear of obstructions to allow for easy access and maintenance. Regularly inspect the disconnect switch and wiring for any signs of wear or damage. Check for loose connections, corroded terminals, or damaged insulation. Repair or replace any damaged components as needed to maintain the safety and reliability of the electrical system. When making the U-turn inside the disconnect, avoid sharp bends in the conductors. Sharp bends can damage the insulation and reduce the conductor's ampacity. Use gradual bends with the proper bending radius to minimize stress on the conductors. If the conductors are too stiff to bend easily, consider using a cable bender to help shape them. A cable bender can provide leverage and control to make smooth, consistent bends without damaging the conductors. When routing the conductors through the enclosure, avoid crossing them or creating unnecessary loops. Keep the wiring neat and organized to facilitate troubleshooting and maintenance. Use cable ties or other securing methods to keep the conductors in place and prevent them from tangling or interfering with each other. If multiple conductors are running through the same conduit or enclosure, direct their ampacity according to NEC Table 310.15b3. This table provides adjustment factors for conductor ampacity based on the number of current carrying conductors in a raceway or cable. Dirting is necessary to account for the increased heat generated by multiple conductors in close proximity. When installing the disconnect switch in a damp or wet location, use a NEMA 3R or NEMA 4 enclosure to protect it from moisture. These enclosures are designed to prevent water from entering and damaging the electrical components. Use watertight fittings and connectors to maintain the integrity of the enclosure. When installing the disconnect switch outdoors, protect it from direct sunlight and extreme temperatures. Prolonged exposure to sunlight can cause the enclosure to fade and crack, while extreme temperatures can affect the performance of the electrical components. Consider using a sun shield or other protective measures to extend the life of the disconnect switch. If the disconnect switch is located in an area where it is likely to be exposed to physical damage, such as from forklifts or other equipment, install barriers or guards to protect it. These barriers can prevent accidental damage and ensure the continued safe operation of the disconnect switch. Regularly inspect the barriers and guards for any signs of damage and repair or replace them as needed. When replacing a disconnect switch, be sure to use a replacement that is compatible with the existing wiring and equipment. Check the voltage and current ratings of the existing disconnect and select a replacement that has the same or higher ratings. Also, ensure that the replacement disconnect has the same number of poles and the same type of terminals as the original. Before removing the old disconnect switch, take photographs or make detailed notes of the wiring connections. This will help you to ensure that the new disconnect is wired correctly. Disconnect power before working on electrical equipment. Using proper personal protective equipment is an important part of staying safe on any electrical project. Always test the circuit to make sure it is de-energized. Always verify there are no exposed live connections, and that connections are properly torqued and that there are no sharp bends in conductors. Always follow the manufacturer's instructions and any applicable codes and standards. The NEC will be the most relevant set of standards and practices. When installing the disconnect switch, consider the location of other electrical equipment and structures. Ensure that there is adequate clearance around the disconnect to allow for safe operation and maintenance. Avoid installing the disconnect in areas where it could be easily damaged or obstructed. Properly sized conductors are essential for safety and performance. Remember to always choose the appropriate conductor size for the application. This will help prevent overheating and other electrical problems. Use properly rated electrical tools when installing and maintaining the disconnect. Electrical tools are designed to provide insulation and protection from electrical shock. Avoid using damaged or defective tools, as they can pose a safety hazard. If you are not familiar with electrical work, hire a qualified electrician to install or maintain the disconnect switch. Electrical work can be dangerous, and it is important to have the knowledge and skills necessary to perform the work safely. Obtain the necessary permits and inspections before installing or modifying electrical equipment. Electrical permits and inspections help to ensure that the work is done safely and in accordance with applicable codes and standards. Keep accurate records of all electrical work, including the date, description of the work, and the name of the person who performed the work. These records can be helpful for troubleshooting and maintenance purposes. If you have any questions or concerns about electrical safety, consult with a qualified electrician or electrical inspector. They can provide guidance and advice on how to work safely with electricity. Stay up to date on the latest electrical codes and standards. Electrical codes and standards are constantly evolving to reflect new technologies and safety practices. By staying informed, you can help to ensure that your electrical work is safe and compliant.